Welcome to Lecture 2, Part 2, Timers. Timers are crucial modules in your microcontroller unit. All microcontroller units will have a timer module which provides some temporal relevance, a bit like how we dictate time. In your microcontroller, everything and every operation is executed in clock cycles, but that clock cycle is dictated by the crystal frequency or the clock frequency. So different boards will have different crystal frequencies, and you should refer to your board schematics or your microcontroller unit's datasheet to determine that frequency. Timer operations can include using the timer from the clock source, using it as a counter from external sources. It can also be used for signal generation and can also form a capturing and measuring mechanism. So within your AVR, there are 3 timers that you're allowed to use. 2 of them are for use with internal clocks. So you have timer 0 and timer 1. So timer 0 is an 8-bit timer or counter with PWM output capability. Now, timer 1 is a 16-bit timer counter with PWM output capability as well. And with these 2 timers, you can select a number of predefined prescalers to prescale your clock input. In contrast, you have timer 2, which is an 8-bit timer counter which has PWM capability and an asynchronous operation capability. So you can use an external asynchronous clock source to operate the timer 2 counting. Now it also allows a 10-bit defined prescaler for timer 2 rather than the predefined select few. Now timers work by continually counting up until it overflows. For example, in an 8-bit system, there is only counting from 0 to 255. Once the timer is at 255 and the clock ticks up, your timer overflows. Similarly, with a 16-bit timer, you are allowed 65,535, and at the next clock cycle, that timer will overflow. Now, when a timer overflows, it triggers an interrupt, and it doesn't reset the timer when an interrupt occurs. Configuring the timers for use is done in the control registers. So based on how you set up the control register or registers, you define the operation of the timer module itself. So notice that there are multiple registers for a specific timer module, which might provide different capabilities. Looking at the AVR architecture, you can notice that there are 2 control registers for a timer module, and each register will be in charge of separate functionalities within the timer itself. So you should refer to your datasheet to find out these control registers, and also potentially look at how the control registers are linked to your timer module itself in the block diagrams. There are a few things to consider when you're using timer modules in your microcontroller unit. The main 4 are your internal clock frequency, the number of clock cycles, the prescalers if it's usable, and the starting count to set for your timer module itself. So using the clock cycles, so as mentioned before, we have the internal clock frequency, which is dictated by the crystal frequency of your microcontroller. So you should refer to your datasheet or your schematics to determine the actual clock frequency. Once you have that, you can calculate the length of time you need to use the timers for. So that's your clock cycles, which is your frequency multiplied by the time. Now, I mentioned the prescalers because a 1 to x prescaler means that for every x clock cycles, the timer will increment. So a reaction to this is that, let's say you have a 1 to 16 prescaler. It will mean that 16 clock cycles will have passed before your timer counts up. In effect, this lowers the resolution of your timer by 16. So this is something worth thinking about depending on the application you're trying to use. So if you're trying to detect something that happens within or between the 16 clock cycles, you won't be able to detect it until the 16th clock cycle has passed. Finally, remember that the timer triggers an interrupt by overflowing. As mentioned before, an 8-bit timer overflows when it is at 255 and the clock cycle ticks up. So calculating your starting count will determine how long before an interrupt is triggered for your system to handle in the interrupt service routine. So these are just some of the components to think about when you're using timer modules. Now, definitely there are other modes that you can use with the timer modules, such as the counter mode and the compare or capture or PWM mode, and we will get to that in a future video. Since the timers are intrinsically linked to interrupts, similar to the interrupts video, we mentioned resource management is a big component, and this is the same over here. Effective resource utilization with the limited number of timers you have is key for your application using the microcontroller units. So let's look at an example when you have multiple timers and how you can manage that. So let's look at an application where we have 2 timers running with an external interrupts. The external interrupt counts the number of external signals that is being triggered to your microcontroller unit, and it's roughly about 500 signals every 6 seconds. And you have 2 timers running. So timer 0 is running and is counting every 2 seconds using a 1 to 256 prescaler for your data logging, and timer 1 is counting every half a second with a critical component, which is calling a specific function in your main program. Now, this specific function is critical in the operation of your microcontroller unit as it affects the manufacturing line. So you compile your program and you run the program. It runs, but it's buggy. So it's quite slow, and randomly it will skip specific calls in your main program. So thinking back at the previous slide where we mentioned a few things to consider when you're working with timers, what information is needed for you to debug these issues given this setup? So I will recommend that you look into how the timers are being set up and looking into the capabilities and functionalities of the timers to try and extract what information is needed. So have a think about this and bring that thought into class where we will discuss this further.